Welcome class to the Math 2015 video for Learning Outcome 5, Day 2. So in our last video, we had gone over some ideas of what equation stacks are and what equation strings are, and how to make sure that equation strings have all parts of between the equal signs to be the same value. Then we ended with two links to Number Talk videos that are found online. With the Number Talk videos, the teacher had tracked each of the students' solutions to various problems using equation stacks. This second half of Learning Outcome number 5 the objective is to write each of the equation stacks into an equation string. And when you take in, and you can point out some areas where you can push students for further thinking. The trick is, in general, is to make sure that all of the equations in the equation stacks are figured into the equation string. And I'm also going to write down some properties of arithmetic that are used along with the questions in the equations string, so you can see how properties of arithmetic help make mental math go a lot easier. Okay, so in general, after watching the Number Talk videos, how impressed are you guys with how the students could think so deeply? I was impressed in second graders and in the fifth graders. When the teacher conducted Number Talks, first wrote the problem and then the answer, one possible answer from a student, and then the teacher polled the students for even more answers, which can be dealt with one by one until the class decides on which is the right answer. Once the right answer is found, the teacher polled the students to see what kind of strategies were used. Okay. In the first Number Talk, the problem was 176 plus 98, which the students found was equal to 274. The strategies are going to be again written as equation stacks, and we're going to translate those into equation strings. When the teacher did the Number Talks, they said to think of different strategies and use your thumb. Put your thumb to your chest if you got 1. Extend your first finger if you got 2, and your second finger if you got 3, and so on. Then the teacher wrote down the problem, as I have there, and gave wait time. And the wait time in the first class was almost a whole minute, which seemed like a long time. But the students need that time to find the answer and find their strategy. And so as the teacher asked for different answers, the students who agreed with the strategy or came up with the same strategy did also a nonverbal sign. So those types of ideas make a great Number Talk situation. The first strategy of 8 total strategies, here's the equation stack that was written on the board. (176 plus 98). And then the student said, well, I'm going to do 98 plus 2 equals 100. 176 plus 100 is equal to 276. And 276 subtract 2 is equal to 274. Okay, and the teacher pushed on where was the 2 coming from, right here. And the student had said that it was coming from whatever is needed to get to the 100. And teacher then asks, why do you want the tens complement? Why do you want the complement? For the 2, 100, why would you want that? Make it easier, right? Now that's the equation stack, and what we're going to do in this video is we're going to draw a line here. Let's draw a red line here. And we're going to go ahead and write the equation string. The string is a set of equations that are put in one long line. And so since I don't have much room on this half of my paper for the video for my long line, I'm just going to put it all together, but in more of a stack form. But the difference is that the equation string needs to have equal signs throughout. Every line needs to be the same value. Every part of the equation needs to be the same value. Notice that in the equation stack, all that was going on was, make a t-chart here. All that was going on was 98 plus 2, 176 plus 100, 276 minus 2. All of those are different values. Okay, we're going to stack the equations so that they all have the same value, or string up the equations so that they all have the same value. Now, what the student did is that they did the plus 2 minus 2 thing. So that's the key for this equation string. In order to maintain all the equals parts, we need all the parts equal. We need to consider the whole strategy as one, and operate on each of the parts of the equation just as the student did, or as close to as we can. So for the homework, just do the best you can, make the strings equal, all parts equal, and try to follow the student's thinking as much as you can. Staying away from standard algorithms because the students don't usually use them when they're doing the mental math. Okay, so 176 plus 98 is equal to 176 minus 2. Okay, so I introduce the negative 2, the minus 2, into the equation because I need to add 2 to the 98. Okay, so when I subtract 2, add 2 to one side of the equation, that does not change the value of the equation. Okay, so that way this left half and the right half are the same in the equation, same value. And so I'm going to go ahead and since I don't have any room to go off of this side of the equation, I'm going to go down below it. And 176 subtract 2, I'm going to maintain, because the student doesn't subtract 2 until the very end. Okay. So we have to keep that separate until the end if we want to model as accurately as possible. Now what the student does do is add 98 and 2. So I'm going to go ahead and do that and make it add to 100. And what the student did was, you can do a commutative property or an associative property, but whatever you need to do, you need to get the 176 to the with the 100. Okay, so from here to here, I did the commutative property. Abbreviate it like that. The commutative property. No, I can't see that very well. Let's do this. Okay, the commutative property. Now we can add the 76 and 176 and 100 together to get 276 minus 2 is equal to 274. Okay, so notice that every part of the right side of my equation string, or all those parts of the equations, are equal, and they've modeled each of the thoughts of the student. Okay, that's my first strategy. Number 2. The second strategy is has an equation stack that follows. Once they started with the problem, 176 plus 98. They added 8 plus 6 equals 14. Then they did 170 plus 44. No, sorry, plus 14. The one that 14 from above there is equal to 184. Then they did 184 plus 20 equals 204. And 204 plus 70 is equal to 274. What can we look at here with questions? From this row to that row with a stack, the teacher asked, how did the student get 184 plus 90? Oh, darn it, I skipped that one. Okay, let's go ahead and go back to this one. I apologize. The student had did 184 plus 90 and finished the problem. And then the teacher asked, how did you get 184 plus 90? How did you do? Okay, and then the student clarified, or another student had responded, I can't remember. I said, well, all I did was take 184, add on 20 to get to 204, and then I did 204 plus 70 equals to 274, because that's what's left from the 90. And so a teacher can ask, why split the 90 into 20 and 70? Okay, and then the student can talk about, well, 20 is all it needs to get up to the next 100, and so on. Okay, let's put this together in the equation string. We're taking 176 and we're going to add on 98. Now what the goal is to model the student's thinking. What the student did first was add 8 and 6. So we got to pull out the 8 and 6 from wherever they are. And that's the 6 is on the 176 and the 8 is on the 98. So when you separate the 176 into 170 plus 6 and the 98 into 90 plus 8. Now we got to get 6 and 8 to add together next. So we won't worry about the parentheses. And then we're going to use the commutative property to switch the 90 and the 6. So we can get the 6 and 8 together. And so we want to be able to add the 90 and the 6. So yeah, this is the commutative property here. Okay, we got that one there. We add the 6 and the 8 together. But normally we're going to be adding the 170 and 90 together, right? So we're going to add 6 and 8 together next. And that's the associative property. Then we go ahead and add those together. Okay. The next, after getting the getting the 8 and the 6 to the 14 is added to the 170. So we need to use the commutative property to get the 14 and the 170 together. Excuse me. And then we're going to add the 170 and the 14 to get 184. Now, the 184 and 90 were put together by the original student to get 274, but the teacher had pressed the student to explain why 184 and 90 gives you 274. And this is what another student said, or the 90 was broken up into 20 plus 70. So we can split that up in our next expression part of the equation. And then I'm putting the 20 first because the student added 184 and 20 next. So 184 plus 20 is next. And this can be done using the associative property. Okay. And now 184 and 20 make 204 plus 70. And the answer to that one is 274. Okay, so hopefully you guys are getting kind of the idea of how to translate equation stacks into equation strings. Okay, that was example number 2. Example number 3. Equation stack. Now this one in number 3, $176 plus 98. Remember, we're showing lots of examples so you can see the process that it goes through. Process is what's most important. So the student in the third explanation or third strategy started by saying 198 plus 2 is 200. Okay. Then they said 200 plus 70 is equal to 270, and then 270 plus 4 is equal to 274. Now the teacher had pressed, and where did the 2 come from? And then it was also asked, how did you break apart the the 176? Okay. And so these we must go from what the student said or deduce, so we can get the correct equation string. Okay. So here's the equation string. We start with our problem. 176 plus 98 is equal to the first thing that was added the first thing that came was 198. Okay, and so we need to get take the 98 and turn it into 198. And you can do that by splitting off the 100 from the 76. So we can do 176 plus 98 equals 76 plus 100 plus 98. And we're going to use a property to associate the 98 and the 100 before the 76 and the 100. And that's the associative property of addition. Okay, so we got to get the 76 plus 198 together now. So that's where we are at with the first thing, the 198 idea. Okay. The second thing is then you get to 2. Where does the 2 come from? And I think the student said that the 2 came from the 176 because the student has both 2 and 4 being added. Okay. So we need to break up the 70 6 into 74 plus 2. So we can put that 2 with the 198. And if I put the 2 with the 198, I can use the associative property to make that happen. Okay. Now we have 74 plus 200, which is where the next step comes in. 200 plus 70 is equal to 270. So we need to take our 74 plus 200 and split up the 70 so that we can do... Oh wait, no, not in this one. Yeah, in this one, we split up the 70 so we can do... $70 plus 4, which is what the last two steps are. And so we're going to do... So we split up the 74 to 74, and then we add the 71st to the 200. So we can use the commutative property to do that. Okay, there we go. And then we can add those two. Okay, and we get our 274 from there. Okay, number 4. Strategy number 4 has an equation stack that was recorded as such. 176 plus 98. Then 8 was split up into 4 plus 4. And the 176 was being added to 4 to get to 180. The 180 was also added to 4 to get to 184. And so the next, the student had added 184 and 20, but in order to help us know where that came from, the student in their mind separated the 90 to 20 plus 70 to get that 20 to come out to the 184. Okay. Now the 70 will also be added to the 204. To get to 274. Now, questions that you can ask in this step is why break up 8 and 198 and just the 98 to do 4 plus 4? Why break up the 8 into 4 plus 4? And why break up the 90 into 70 plus 20? Okay, we know that we want to make some tens complements to compensation for that, so that's probably why they did that. Make it easier for them. Now we're going to go with our equation string. 176 plus 98. Now the first thing they did was they broke the 98 up into 4 plus 4. So we got to get the 8 off of the 90 and then break that up into 4 plus 4. So 176 plus 90 plus 8. Same as 176 plus 90 plus 4 plus 4. Okay, now I need to get the 4 to 4 to add to the 176. So we use the commutative property to help us. We can take that whole quantity and move it along. So it's commutative property. Okay, 176 plus, oops, you get that 90, let's not forget the 90. We had switched them. There we go. Okay, we switched them. Not lost 190 or 90. Next, we're going to do 176 plus the 4. And when we do that switch of the which we're associating there, that's the associative property. We switch that 176 and the 4 to get 180 plus 4 plus 90. Okay. Now we're going to add on the 4 to get 184 plus 90. And then the 90 was taken care of especially as it was broken up into 20 plus 70. Oops. Okay. And then the 184 plus 20 happened first, and then we add on the 70. Now when we switch the association to 220 plus 70, 284 plus 20, that's the associative property that can help us. And when we do that, we have 204 plus 70, which was equal to 274. Okay. All right, so you have some good strategies. I recommend taking a break, and we'll come back for strategies 5 through 8 for this. All right, I'm coming back to strategy number 5. We have the equation stack. That was given in the video. The student said to add 176 plus 98. And they broke up the 6 into 2 plus 4. And then they add that 2 to that 8 up there. And so I wrote implicitly that 98 plus 2 was equal to 100. And then from there they had 174 plus 100 equals 274. Okay. And this approach is probably the simplest way to find the sum of 176 plus 98. And so you can ask the student, why did you break up 6 into 2 plus 4? Okay. Now the equation string goes like this. 176 plus 98 would equal maybe something like this. So the student had broke the 6 up into 2 plus 4, so let's do that with our 176 as well. Into 174 plus 2 plus 98. Then the student had added the 2 to the 98 to get 100. So 174 plus the quantity 2 plus 98 was done next. And so we can do that by using the associative property. And then we have 174 plus 100. And then the student had just summed those to 274. Okay. Strategy number 6. Starting with the equation stack, the next student in the video added 176 plus 8 and got 184. And then they added 184 plus 90 to get to 274. Okay, and if I were a teacher, I'd press on this one and this one. Why did you add the 8? And how did you get 274 from that big step? So another kid had chimed in about the last question about how they got 184 plus 90 is 274. So another student said, for 184 plus 90, can break the 184 into 174 plus 10. Because 90 and 10 makes 100, so we put the 10 with 90 plus 10 equals 100. So the student said that last line, we need to understand that what 184 was broken into in order for to understand the student. So 174 plus 100 is then equal to 274. Okay, so that's the equation stack with 2 students on this strategy. For the equation string, again, we want to incorporate all of this thinking that students did. So adding 8 to 176 was done first. So the 98 had to have been broken up into 90 plus 8, and then the 8 added on. Okay. Starting with the original problem, we want to break up our 98 to 90 plus 8. And then we're going to use a commutative property to get the 8 next to the 196. So they can add together, because that's what the next step was, 176 plus 8. And that was 184. Now the 184 plus 90 was demonstrated by another student, and the other student had broken up the 184 into 174 plus 10. So we can go ahead and do that as well. And then we'll use the associative property to associate the 10 and 90 instead of the 174 and 10. Okay, so that's associative property. And that 90 and 10 can be added together. And then we get 174 plus 100, and then we get to 274. Okay. A couple more strategies. Number 7. Equation stack. What this student said is 176 plus 98 should be done by subtracting 6 off of 176 and getting 170. then taking 98 and splitting it up into 30 plus 68. And you can ask the student why they chose to subtract 6. Why subtract the 6? And then why split up into 30 and plus 8? I imagine that they will say things like they're going to get to the 10th complement, up to hundreds complements, so making the addition easier. So they split the 98 into 30 plus 68. Then they said to add 170 plus 30 is equal to 200. 200 plus 68 is equal to 268. And then 268 plus 6 is equal to 274. Okay? So we want to kind of sort out the mathematics here. The student obviously got the right answer, so they're thinking it's probably correct, but why? Why is it correct? So we can do that with the equation string. (176 plus 98 is equal to). Now, if I want to subtract 6 off, go ahead and do that. But I'm going to add 6 at the end. So notice that there's a minus 6 here at the beginning and a plus 6 at the end. And so we can take care of both of those with this line and then keep the 6 along for the ride. So I'm going to split up my 176 into 176 minus 6 plus my 98, and then I'll have to add 6 onto that to keep things equal. So we have 170 plus 98 plus 6. I'm going to keep the 6 apart until the end because that's what the student does. Now next the student splits up the 90 into 30 plus 98 into 30 plus 68. Keeping the 6 along for the ride until the end. Now there's a property that says that we can associate 170 and 30 together, then add 68 and the 6 at the end. That's the associated property. So 200 plus 68 plus 6 is now where we're at. And then the student added the 68 onto 200, so that makes 268 plus 6, and then the student added on the 268 and 6 to get to 274. Last strategy for this part, which we will probably just skip because in the equation stack, so we'll show you, we'll skip a lot of it. The student had just added on plus for 176 plus 98, they just added on 10s. 176 plus 10 equals 186. 186 plus 10 equals 196. And they did that all the way down to 266 plus 10 is equal to 276, which was too much. So they added on a whole 100, 10 sets of 10, and then they subtracted the 2, because 98 is 100 minus 2. Okay. Now if you want to go with the equation string on this one, you'll have to do 176 plus 98 is equal to 176. Now that what they did is they just kept adding 10s. So plus 10, as many as you need to get up to 100, and then subtract 2. Okay, so this right here is 10 sets of 10. Okay. And so they did that one by one. They kept adding them on. 186 plus 9 sets of 10. And so on until they got to 276 minus 2, which is equal to 274. Okay. All right. So next is the next number talk, 6 times. In this number talk, we are going to do 6 strategies for 6 times 15 that the students thought of. The teacher put the answer on the board, the problem on the board, did a wait time of about 37 seconds, and then set equal to 90, which there were no other answers to resolve, and began writing down equations in equation stacks. The first student's strategy was 6 times 15, was that they broke up the 6 into 4 plus 2. And then they did 15 times 4 equals 60, and 15 times 2 equals 30. Then they added 60 plus 30, and they got 90. Okay. This is a very typical strategy to break the numbers up and use the distributed property to help you find the total. And why break up the 6 into 4 plus 2 could be a good question to ask. Okay, so let's see how this will work as an equation string. We use this to verify the correctness of students' answers. We start with our problem, 6 times 15, and we set that equal to, we need to break up into 4 plus 2, so 6 became 4 plus 2. And then the times 15 comes along for the ride, because that's to maintain things equal. Okay. Now, then the student did 15 times 4 and then 15 times 2, which came from the distributive property. 15 times 4, 15 times 2. Fifteen times 4 was 60. 15 times 2 was 30. The sum was 90. Okay. And the distributive property was used from this step to this step. And distributive property was very useful to do mental math for multiplication. Okay, you'll see it used throughout here. Strategy number 2. The following was made into an equation stack from the students' thinking. Six times 15 was the problem. Then they said that 15 plus 15 was 30. Then they said that 15 plus 15 was also 30 again. And then that 30 plus 30 was 60. And they realized that they had only 4 sets of 15, so they added another 2 sets of 15. 15 plus 15 is 30. Then the total was 60 plus 30 equals 90. Question you can ask is, where is the 6 in the strategy? And this is what this teacher asked. Where is the 6 from the 6 times 15 in this strategy? Okay, and the student that had answered this question had identified the groups of 15 here, and that there are 6 groups. So the 6 is all split up among all of the 15s there. So that's kind of what we're going to do with our equation string. Is we're going to take our 6 times 15 and split them up into 6 groups of 15. because that's what 6 times 15 really means. So we're going to add those 15s together in the way that the student had grouped them together. And that was with groups of 15 plus 15 equals 30. Okay, now the student did 2 groups at first, so that's going to be these 2 groups here, and then this one last. Okay, so we'll keep that one along for the ride as we add these together, that last group. Now, this 15 plus 15 equals 30 here was from this one, and so on. Oops. That 15 and 15 is 30, and this 15 plus 15 comes along for the ride because the student does 30 plus 30 equals 60 first before adding on more. Okay, so we'll just keep that coming down our equation. And then next, the student added those last 2 15s, and then they added the 60 and the 30 to get 90. Okay, so that's how equation strings are working. You got model what the student thinks with equations to make sure they're all correct and all the steps are equal. Good algebra exercise. So that was number 2. So let's do strategy number 3. Okay, we have to look at a lot of strategies so that we can get an idea of what students typically think about these problems. And you can see like how much math you need to know and how good you need to be at it, this arithmetic. Now, the equation stack for this one is 6 times 15 for the problem. The 15 was split into 10 plus 5. Then 6 times 10 was done to equal 60. And 6 times 5 was done to equal 30. 60 plus 30 is equal to 90. And the teacher could ask the student, why break up the 15 into 10 plus 5? Okay, and breaking up for multiplication is very helpful to do mental math. So you can break up the 6, as in the first couple strategies, or the first strategy, and then break up the 15 and then the third one. And we'll see more breakups here in the next few strategies, but this one broke up the 15 into 10 plus 5. And so 6, for the equation string, 6 times 15 is equal to 6 times the quantity 10 plus 5. Okay. And then the student did 6 times 10, 6 times 5, so that means they must have used the distributive property, distribute the 6 to the 10 and to the 5. Okay. Then they calculated the partial products here. The products here, 6 times 10 is 60, 6 times 5 is 30. And then 30 plus 60 was the 90. Okay. Now, which property was used in this equation string? From right here to right here, the first line to the second line was the distributive property. Okay. Strategy number 4. So the equation stack. The student did 6 times 15 as breaking up the 6 into 3 plus 3. Then the student broke up the 3 into 2 plus 1. Then the student combined these two ones to become another 2, and therefore found 3 sets of 2 for the 6, breaking up the 6 into 3 sets of 2. Then the student did 15 times 2 is 30, so that's any sets of 2 of 15 are going to be 30 each. And since there's 3 sets, they did 30 plus 30 plus 30 equals to 90. Okay. So let's write that as an equation string. So 6 times 15 is equal to, the first breakup was into 6 into 3 plus 3. So 6 times 15 is the same as 3 plus 3 times 15. Now they broke up the 3's into 2 plus 1's. So each 3 became 2 plus 1. That original plus is still there. And then all of that's times 15, so I'm going to use these brackets here to keep everything times 15. Then those two 1's became a 2. And we need to put those two 1's together in order to do that. So 2 plus 2 plus 1 plus 1. Now I'm switching these two here using the commutative property. So let me finish this part out. Times 15 there. And so from here to here we use the commutative property. Alright, so the 2 plus 2, those two 1's became another 2. And then the 15 was carried along for the right again. Now I'm going to, eventually we want to get to 15 times 2, and we want to get all the 30's, those three 30's added together. So in order to do that, we have to distribute the 15 to this 2, into that 2, into that 2. So we can get 15 times 2 for that operation that the student did. But the student did it 3 times, even though it was only recorded once. So we got 2 times 15 here, plus 2 times 15 here, plus 2 times 15 here. Okay, and from here to here, we went distributive property. Okay. Now all of those 2 times 15's became 30, and then that's when the student added those three 30's together to get to 90. Okay, you guys are doing great. Strategy number 5. Strategy number 5 has an equation stack and an equation string. Now the equation stack for the 5th strategy that the student did, I think strategies 5 and 6 were kind of like dovetailed off of the 4th strategy, but they actually presented different types of thinking. So I went ahead and wrote them down as different strategies. So 6 times 5, again we break the 6 up into 3 plus 3. And this strategy where the student didn't actually kind of take a long way around to get about it, they did 3 times 15 is equal to 45. And 3 times 15 is equal to 45. Okay, so they broke the 6 up into 3 plus 3, and they did 3 times each of those 15's, the 15 times each of those 3's, and then they added the sum 45 and 45 together. So that's kind of a shorter strategy, and we're going to go ahead and do the equation string for it. Six times 15. 6 is broken up into 3 plus 3, and then do times 15. 3 times 15 plus 3 times 15. Okay, from this, the first line to the second line, we use the distributive property by distributing the 15 by multiplication over addition. 15 times 3, 15 times 3. So the 3 times 15's was 45's. Oops, and I forgot the 45 plus 45 was 90. So the last part of the equation stack is there now. And those became 45's on the equation string. And then 45 and 45 makes 90. Okay, these ones are a bit shorter than the addition ones, which is good. Number 6, last equation strategy. Equation stack. 6 times 15. Now this student said that they take half of 6 and they double 15 and they get their answer. Well, half of 6 would look like this. 1/2 times 6, which is equal to 3. Then double 15 is 2 times 15, which is equal to 30. And the student said that they went ahead and multiplied 3 times 30 to get to 90. Okay. So how would this look like as an equation string? Does this work all the time? Well, let's see. So 6 times 15 is equal to, we need to get the halves and the doubles in there. But there's no twos or halves in there right now. So we need to kind of generate it from using our identity. 1 times 6 times 15. So I'm going to take that 1, I introduce a 1, and split it into 1/2 times 2. Okay. And then I'm going to use the commutative property to get the 1/2 and the 6 next to each other, because that's what happens in the student thinking at this step, 1/2 of 6. Okay, so I'm going to switch these two together to make them together like this, which actually makes the 2 and the 15 go together, which they wanted to do in this step. So that worked out well. And 1/2 times 6 is 3. And we have the 2 times 15 at the end there. Normally, we do 3 times 2 first, in the order of operations, but we don't have to with the multiplication. We can do 3 times 2 times 15 next. And that's what the student did. They calculated the 1/2 of 6, then they did the 2 times 15, which became 30. And 3 times 30 is 90. Okay. So this strategy that the student introduced last, you can use the last strategy of doubling, of having and then doubling, having the first number, doubling the second in a product with any even multiplication fact. So we look for strategies to help the students learn their multiplication facts in like 4th grade. And we have 4 times 6, for example. If we half 4, so we have half of 4 is equal to 2. We go ahead and double our 6, this is the second number, which is equal to 12. We can say that 4 times 6 is the same as 2 times 12, which is equal to 24. Okay, so having the first number, doubling the second. Okay, so here's another example. 6 times 5. Half of 6 is equal to 3. Double 5 is equal to 10. That means that 6 times 5 is the same as 3 times 10, which is equal to 30. Okay. Okay, so that's the video on number talk strategies for your equation stacks, and then how to convert them into equation strings. Okay, hope you guys enjoyed the video.